All right, guys, welcome chapter 13.2 extension slopes of parallel and perpendicular lines. So last section we were talking about the slopes, and now we are going to continue with the slopes. We are just going to look at multiple lines on the same graph and test whether or not they are parallel, perpendicular, or neither. So like I said, we're doing today, identifying parallel and perpendicular lines. First, we want to review slope. Not sure how long ago you looked at the previous PowerPoint that I gave you guys the video, but let's just look at slope. Talking dog, what the? All right, remember, you can have a positive slope, a negative slope, slope of 0, and an undefined slope. That's right, there's only 4 types of slopes. There's no more types of slopes: positive, negative, 0, and undefined. And undefined, remember, is so big, the number is so big that we can't put a number to it. It's not defined because the slope is so high, and that's because it's a vertical line. All right, so remember, slope is the rate of change. It's how much we are changing from one point to another point. So if we look at these two graphs here, and again, wait for my thing to load, we can find the slope. Just look from one point to another point. So looking at this first graph on the left, let's see. We're going to start with the point 1, 120, and then 2, 140. And then we're going to see how much we rise, how much we run. That is going to be our slope. So here we go. Look, we're going to rise up that amount, and then we are going to run over from one point to another. So notice here we went plus 20 because we went from 120 to 140, and then we went from 1 to 2, so we went plus 1. So the slope here, we rose 20, we ran 1. Well, 20 divided by 1, yep, just 20. So our slope for the first one is just 20. For the second one, let's review what it looks like when we use 2 points. We have 4, 4, and we have 2, 3. So we have 4, 4, and 2, 3. Remember, we can do these ones first. So 4 minus 3 over these ones second. 4 minus 2. So m is going to equal 4 minus 3 is 1. 4 minus 2 is 2. So our slope here is 1/2. Right? And notice we rise 1, we run 2. So that would be 1 over 2. It's the exact same thing. So that's kind of a recap on how we're doing slope. And we're going to be doing that the exact same way today. We're just identifying whether or not 2 different lines on the same graph are parallel or perpendicular. All right, so looking at the next slide, we need to first see what parallel versus perpendicular looks like, right? Well, notice parallel lines. Horizontal, vertical, it doesn't matter, but they are basically the same line, just in a different position, right? 2 lines that are the same, even though they're not exactly the same, they look the same, but they're in different positions, right? But they're facing the same way, right? So parallel, 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 not parallel, right? And then perpendicular, make a T, right? But not only do they make the T, they make that square. Remember, that square means 90 degrees. So parallel lines never meet because they are the exact same line in a different spot. And perpendicular lines make 90-degree angles. That's what that square is, right? That square means 90 degrees. So not only is that upper first quadrant 90 degrees, but all 4 quadrants, all 4 corners there are 90 degrees, right? That would make 360 degrees. So all 4 are 90 degrees. All right, so let's look at parallel versus perpendicular. Yeah, we know what parallel lines look like. Yeah, we know what perpendicular lines look like, but what do they look like when you're given an equation? Because you're not always going to be given the graph. Here you're given both, but sometimes you're just given the equation. So the first one on the left, notice y equals 2x plus 3. That's a slope of 2. I even put it in red, right? The slope is 2 on that upper line. And that bottom line on the left side, y equals 2x plus 1. Notice that also has a slope of 2. So I wonder what you guys think about those similarities with a parallel line, right? Now, perpendicular lines meet at 90 degrees. So y equals negative 3/2 x plus 4, and y equals 2/3 x plus 1. What do you notice about the similarities there? I want you to think about that for a second. Parallel lines look at the two slopes. Perpendicular lines look at the two slopes. There's definitely some similarities. So you can pause the video for a second and think about it, but I'm going to move on to the next slide. So parallel versus perpendicular. Notice if we have a random line, the slopes, let's just say is 2/5. If we have another random line, but they're parallel, the slope is also 2/5. The reason for this is because if two lines are parallel, they have the exact same slope. The slopes are not different, they must be the exact same. In perpendicular, say you have one line, say it's 2/5 again. But if we make a perpendicular line, that needs to cross at 90 degrees. The slope's not going to be 2/5, right? Notice how the blue line is the positive slope. Well, if you look at the red line, see how it's negative? So your answer for the slope must be negative. So it's not negative 2/5 though, it's negative 5/2. So notice not only did the sign switch, but we took the reciprocal. 2/5 became 5/2, and we did the opposite sign. What we call that, we call the two slopes of perpendicular lines the opposite reciprocal. So if lines are perpendicular, they have the opposite reciprocal slope. The slope is flipped and the sign is switched. So this is a very, very important slide. Parallel lines have the same slope. Perpendicular lines have the opposite reciprocal. You flip it and you switch the sign. All right, let's go ahead and do one example of which two lines are parallel, right? So that means we need to find the slope of all three lines, and then we need to find which of the ones are parallel. Remember, if they're parallel, they have the exact same slope. So let's find the slope of all three, and then find out which ones are the same. So I'm going to use roughly the same color. So we're going to do blue first. So if we have -3, 2 and -4, -2, I'm going to do these ones first. So 2 minus -2 over -3 minus -4. That simplifies to 2 minus -2 is the same as 2 plus 2. 2 plus 2 is 4. -3 minus -4, that's -3 plus 4, which is just a positive 1. So you get -4 over 1, which just equals 4. All right, let's do red now. So 3 minus -2, we're going to do first. 3 minus -2 over 1 minus 0. Remember, we need to be consistent. Since we're using this 3 first, we need to use the 1 first. So 3 minus -2 is the same as 3 plus 2, which is 5 over 1 minus 0 is just 1. So 5 over 1 equals 5. Notice these two are not the same. So these two lines, they look pretty parallel, right? If we were to erase this, I don't know, to me they look pretty parallel, right? But they're not. Just because they look parallel doesn't mean they are parallel. In order for them to be parallel, they must have the same slope. Otherwise, they are not parallel. As much as they look like they're parallel, they are not. All right, and then the last one, we'll use green, right? So we're going to do 1 minus a -3 over 4 minus 3. So you guys are going to notice 1 minus a -3 is the same as 1 plus 3, which is 4. 4 minus 3 is 1, so we get 4. So which of the two lines are parallel? Yep, your answer is blue and green. And then it says to explain. So how could we explain that? Well, blue and green have a slope of 4. Red has a slope of 5. Boom, done. So I'm going to write slope of 4. That's a good explanation. All right. So if you want the actual words, the blue and green lines are parallel because they both have a slope of 4/1 or 4. Done. All right. Don't worry about talking to a partner, right? We're just going to do this on our own. Which two are perpendicular now? Now, I know, at least you guys should know, blue and red are not perpendicular. They don't look like they're going to meet at 90 degrees. In fact, they almost look parallel. They don't look quite parallel, but they look pretty close to being parallel. So either blue and green are going to be parallel or red and green are going to be parallel, right? So we only need to do those two. So first, let's just find the slope of all three lines again, and then let's find the opposite reciprocal to find which ones are perpendicular. So what we're going to do, wait for this to load. First, I'm going to find the slope of the blue line, right? So here we go. If we find the slope of the blue line, then I'm going to do 6 minus 4 over -5 minus 1. Well, 6 minus 4 is 2. -5 minus 1 is -6. Hopefully I'm doing that right. Let's check. -6, or sorry, 6 minus 4 is 2. -5 minus 1 is -6. Yep. Well, 2 over -6, that simplifies to -1 over 3. So our blue line has a slope of -1 over 3. Let's do the red now. So if we look at the red, I'm going to do 0 minus a -2. And then I'm going to do -5 minus 2. Well, 0 minus -2 is +2. -5 minus 2 is -7. So that's going to simplify to -2 over 7. Now, remember we said we're pretty sure those two aren't perpendicular? Yeah, obviously they are not, right? They're both negative. In order for two lines to be perpendicular, they have to have the opposite sign, right? The opposite reciprocal. So since these two are both negative, we know that they are not perpendicular. So now let's go to the green one. The green one's the most important one, right? So we're going to do 5 minus a -2. And then we're going to do 0 minus a -2. Well, 5 minus -2 is the same as 5 plus 2, which is 7. 0 minus -2 is the same as 0 plus 2, which is 2. So therefore, we get 7 over 2. Now, just by looking at this, you guys should be able to tell which of the two are perpendicular. So let's look at the green, because the green is the big one, right? That's the one that we know crosses through both, right? On the graph, we see it crosses through both. So therefore, let's take the opposite reciprocal of 7 over 2. So if I look at 7 over 2, there's two things I got to do. 1, flip. 2, switch the sign. So if we have 7 over 2, first we're going to flip it so it becomes 2 over 7. And then we're going to take the opposite sign, so -2 over 7. So as you guys can see, these two are perpendicular. So which two are perpendicular? We're going to write red. That's a really bad E, but that is red. Let me try to salvage that. Red and green. And why? Because the opposite reciprocal of the green one is the red, right? So let's put that into better words. The red and green lines are perpendicular because the red line has a slope of -2 over 7, while the green line has a slope of 7 over 2. -2 over 7 and 7 over 2 are opposite reciprocals. Done. Easy, right? Not only are we done with that problem, we are done with that section, right? We are done with the extension. So your homework due Friday. It's Friday at 11:59 p.m. I don't know why it says Big Ideas Chapter 13.1. Let's go ahead and get that nonsense out of there right now while this loads. Here, let's see if we can be fancy with it. Yep, we're just going to get rid of that real quick. So Big Ideas Chapter 13.2 extension. Obviously, that's exactly what it says, right? Big Ideas Chapter 13.2 extension is page 580, 581, 1 through 12. All just upload it on Big Ideas, guys. I know you guys all use Big Ideas, but if you want to email it in, remember, that's fine too. All right, guys, we're done. One more section for this week. That's going to be 13.3, which is, please. graphing proportional relationships, which we've already done in chapter 5 or 6. So not too big of a deal, guys. You guys are going to kill it. All right, guys, let's see if I can get out of here. Yep, there we go. You guys have a great rest of your day, and I will see you guys on the Zoom meetings. See you guys.